So I'd like to welcome everybody to today's webinar. As you all know, that's for sure, that there's a huge amount going on in our industry because of the new legislation in New Jersey. This seminar or a similar seminar has been given a few times. And let me tell you a little bit of background of this webinar. A number of people have asked us over the last 6 months or so, or even less than that, when we've been giving this webinar, if it's approved for CAI continuing education units for managers. So what we did is we took a course, and it takes about a month at least to get approval from CAI, not because they question any of the content, but just that's part of their process to get a class approved for credits. This class is approved for credits, but what happened is, as you all know, that there's been so much going on with this legislation in New Jersey and the CAI National's public policy that even the time we sent it to them for approval, it was probably outdated a little. So what I've done is I've taken that presentation that we submitted to CAI for credit, and I've left pretty much everything that was in it, so the credits are still good. But I've added some things, as you'll see, or you may not see, I've added some things because of what's been happening in our world with this legislation. The other thing is I'm assuming that most people here are from New Jersey, although this is set up as kind of a generic presentation based on the topic I'm going to be talking about. But I will mention certain things that relate to the New Jersey legislation, because the New Jersey legislation that relates directly to this was passed on January 8th, and it is a law in the state of New Jersey. Also, we've been getting a lot of questions for interpretations of what the legislation says. So if you have any questions, please drop them in the chat box as I'm going along, and then we'll open up for question and answers towards the end. Questions and answers are the best. To give you a little background, as you know, my name is Mitch Frumkin, and I'm a licensed engineer, and I have my reserve specialist designation. I've been very involved in CAI over the years. I've been president of the New Jersey chapter as well as the Pennsylvania chapter. And on a national level, I've been national president of CAI. I've been president of the National Foundation for Community Association Research. But how it all relates to this is that when Champlain Towers collapsed a number of years ago already, hard to believe, CAI immediately put together a task force. And the purpose of that task force was to develop public policy to be used across the country by legislators so that they could put in place laws to prevent what happened in Champlain Towers from happening again. When CAI created this task force, they asked me to co-chair it. There were, I think, 4 or 5 co-chairs at that time. I was the only engineer as part of the co-chairs. And we reached out to probably over 600 people around the country. We came out with, I'll show it part of my presentation, what it looks like, but a public policy on condominium safety and reserve funding, as well as maintenance. So then that was used in the state of New Jersey, as well as in the state of Delaware. I don't know if anybody here is from Delaware, but Delaware passed a law in Newcastle County relating to this. About, I guess it's 2 years ago already, Senator Singleton in New Jersey came to the New Jersey Legislative Action Committee, which I am on, and said, I want to put together a law in the state of New Jersey to prevent what happened in Florida from happening in New Jersey. So myself, Ed San George, and Dave Ramsey were kind of tasked with being the contact with Senator Singleton in drafting the legislation. The legislation in New Jersey is very much based on the public policy that CAI National came out with about a year or so ago on condominium safety. In the meantime, what has happened is, as the dust was settling, CAI realized that it was time to update the public policy. So they asked me to chair another national task force to update the public policy on condominium safety. I see there's a question. It is being recorded, right, Jody? And we'd be happy to share the presentation. But they asked me to update, yes, to chair a task force nationally to update the public policy. That took about 6 or 8 months. We had a number of people involved in this. And just in the last few weeks, it went through the process, and the CAI National Board has approved the updated public policy. The primary change between the original public policy on condominium safety and the current public policy that's been updated is that it now includes facades of buildings, not just the structure of the building, which I'll touch on as part of my presentation. The New Jersey legislation is based on the original public policy and does not include facades. I will tell you that one of the things that happened during the process is that there was a balcony on a building, and I think it's in Seabright, New Jersey, collapsed, a concrete balcony, and there was a workman that was killed. The balcony is typically included as part of the facade of the buildings. But what we were able to do because of that is we have added to the legislation in New Jersey, which is part of it, that part of the structure that is inspected includes the balconies. So that is included. But the facade as a whole is not, at least in the legislation. But I'm going to touch on also, there are a number of places in New Jersey that have ordinances or whatever you want to call them in place, like, well, I'll talk about them, that do include the facades. So there are also the other thing that's included is reserve studies and reserve funding, which I'll touch on also. So I'm going to give you an overview of all this stuff, like I said, as it relates to the New Jersey legislation. I'll point it out. Most of the stuff, New Jersey legislation and the public policy are in sync with each other. So what I've got, and if you need, by the way, if you need to get credit for this, all you have to do is send to me or Jody, who's here, or drop in the chat box the fact that you'd like to get credit for this continuing education credit as a manager, and Jody will take care of it because I don't know really what we do, but she confirmed to me that the class has been approved. So what I'm going to do is I'm going to share my screen, and like I said, we have 84 people here now. This similar presentation to this has been given a few times, so there may be some repeat customers here, but at the same time, I have updated it, and the questions are very important as I go through. So don't be shy. At the end, I'll open it up to ask questions, but as I'm going along, please put them in the chat box, and Jody will interrupt me. Again, as I mentioned, the start of this was Champlain Towers. I'm sure you've all seen this picture of the collapse of Champlain Towers, and it resulted in New Jersey in the legislation is S2760 and A4384. And as I mentioned before, it started out with the Condominium Safety Public Policy Report, which is on the left. And you'll see under here that it says reserve studies and funding, maintenance and structural integrity. And why that's there is because we quickly realized as part of this task force that building safety is not just based on reserves. There's three things that need to be taken into account, and that is reserves and funding, maintenance and structural integrity inspections. Now, the reason why it says reserve studies and funding is because there are many states out there that have requirements that communities do reserve studies. There are some states that have requirements that community associations do funding. And believe it or not, they don't line up, so they're not exactly the same. And in some cases, you need to fund, but you don't need to do a study. In other states, you need to do a study, but you don't need to fund. So the public policy and the legislation in New Jersey is very specific in terms of both doing reserve studies and funding them. The thing that came out of this task force, as I said, was that we immediately recognized the connection between reserves, maintenance, and structural integrity inspections. So in the public policy, it talks about the inspection portion of it, the structural integrity, but we also realized that the National Reserve Study standards needed to be updated. So what they did is they put together a task force, of which I was on with 3 other people from around the country, and the National Reserve Study standards were updated to reflect maintenance and structural integrity. And you'll see that the legislation in New Jersey refers directly to this standard as the standard to be used, and actually goes over and above what the Reserve Study standards require, and I can touch on that. The other thing CAI realized is that there's really no publication out there from CAI regarding maintenance of buildings. So again, they put together a little task force, which I was on with 3 other people from around the country, and developed a best practices report on maintenance. You're more than welcome. These documents I'm mentioning are free, and we'd be happy to share with you copies of them. But then as you see on the right, that's what the front page of the legislation in New Jersey looks like, which is directly tied into the public policy paper, the standards, and the maintenance best practices report. But keep in mind, what I'm talking about is happening even without legislation. What I'm talking about is something that communities should be doing and not be required to do by legislation, because what this legislation does is it really solves a problem, which I could talk about. And I'll talk about also in the presentation that people are concerned with the cost of this. What is it going to cost to do? And from a life cycle cost basis, which I'm going to talk about, if we do what it says, it's going to cost your communities actually less. But there's also other things out there that making this happen. For example, lending institutions, Fannie and Freddie, have certain requirements now. There are insurance requirements that insurance companies, when you get insurance for your associations, a lot of them, if not all of them now, are asking, what's the status of your reserves? What's the status of the inspections of your building? And what's the status of the maintenance for your communities? So there's other requirements out there. Other thing I hear on the bottom is called community planning. And I like to tell the story that about just a few weeks ago, we got a call from a community in Pennsylvania that wants to put together a reserve study, structural integrity inspections, and a maintenance plan. There's no legislation in Pennsylvania that requires it, but they said this is the right thing to do, and we want to do what the New Jersey legislation requires, even though we're in Pennsylvania. So that's what I call community planning, and that's really cutting edge kind of stuff. As far as Fannie and Freddie, you're probably all familiar with it. This is form, I guess it's called from Fannie, it's called form 1076. From Freddie, it's called form 476A, same form essentially. And this is a form, an addendum to what you need to fill out for Fannie and Freddie these days in order to get approval for lending in your community for refinances and new purchases. It includes a question about building inspections, reserve funding, maintenance planning, special assessment disclosures. They want to know if there's special assessments and what they're for. And these are the forms that's put out by Fannie and Freddie. One thing I always mention is that if you look at the form, question number 1 says, when was the last building inspection by a licensed architect, licensed engineer, or another building inspector? People interpret that to mean that they have to do an inspection. That isn't what it says. It says, when was the last time you had one done? And you could always answer that question to say, we haven't had one done. It doesn't say you have to do it. So be very careful about how you interpret these questions. But these are also other requirements that are going to make you do it. So what are the solutions to the things we're talking about? As I mentioned, it's reserves and funding, maintenance, and structural integrity. And what we do is that if you integrate all of these together, which is what I'm talking about, it will result in structurally safe communities, minimize life cycle costs, and maximized property values. So all of these things are connected. And if you think about all 3 of these together, what everybody should want this for their communities, because it's going to cost them less and it's going to increase the value of their properties. So let's first talk about a reserve study. The reserve study, and by the way, this, for example, is taken directly out of the National Reserve Study Standards, the definition of a reserve study. A reserve study is a budget planning tool that identifies the components of a community association, that a community association is responsible for maintaining or replacing, the status of the reserve fund, and a stable and equitable funding plan to offset the anticipated future major common area expenditures. That's the definition. Now, the legislation in New Jersey refers directly to the standards and this definition. So the question always comes up, which I'll touch on, when you're doing a reserve study, how do you make sure it's adequate? What does that mean? Because the New Jersey legislation and the public policy refer to reserve studies being adequately funded. And I'm going to talk in a little while about what that means to be adequate. So there are a few different types of studies that are out there. There's a full study. It's called a level 1. It's an update with a site visit, and it's update with no site visit. That's called a level 3. So what do these include and what do you need? For a full level 1 study, it includes figuring out what the components are that go on that make up your community, the common elements that will have to be replaced. It includes a condition assessment to look at them to see what condition they're in, so you can establish their estimated remaining life based on the condition. It includes the life evaluation. How long will they last? And how much will it cost to replace them? These are the estimates, which are based on the site visit to look at the condition. It includes a fund status and a funding plan. The funding plan I'll touch on because it specifically relates to what adequacy means. But the fund status means is how strong is your reserve study? And this is a very misleading term, and I'll tell you why. Because if you take a component with a $100,000 replacement cost and a 10-year life, that means that you should be setting aside $10,000 a year. So after 3 years, you should have set aside 3 times $10,000 or $30,000. The fund status means how much of that did you actually set aside? So for example, If you set aside $30,000, you're 100% funded. If you set aside $15,000, you're 50% funded. For one component, it's very important. But if you have many, many components that make up your association, which most of you do, then 100% funding is overfunding, which I'll touch on in a few minutes. Next, we have an update with a site visit, which is a level 2. This does not include a component inventory. You see it crossed out. But what it does say is, and I'm not going to go into a real reserve study presentation here, but the new standards say that you cannot just rely on the old reserve study for the components that are listed. When you're doing a level 2 reserve study, which includes a site visit, you need to look at the community to see if there are components that were not included in the reserve study before that should be included now. That includes a couple of things. There's something that's been, and I'm assuming that we have kind of a knowledgeable audience here about the topics I'm talking about. If you have questions, please ask. But up until this new standard, there was something that was called the 30-year rule, which essentially said anything that will require replacement within 30 years after that reserve study is done should be included in the reserve study as a component. And then as the community gets older, those components that now fall within that 30-year window should be added. So the new standards say a couple of things. They say, first of all, that when you do an update, you have to add those. Before, it did not say you have to add them. And many people would just update the older reserve studies without adding components if they fell within that 30 years because the standards didn't say it. Now it says it. The other thing it now says is that the 30-year rule is gone. So if there's a component that has a 40-year life that falls out of the window, that you can quantify the life and the replacement cost, it should be included in the study. So when you're doing an update now, the main way, there's a couple ways to do that, to include that component and include the funding for it, or to include that component, not fund for it, but at least list it so you know that when it gets to within 30 years, you have to add it. Most people are showing it in the list, but not funding for it because it's going to create a bump in their funding requirements if you have to add that and start funding for it now if it wasn't on your schedule before. Keep in mind that you have to be careful because if you have something with a 40-year life and you're funding it over that 40 years, it's going to be less a year to fund it than if you wait until it's 30 years old and now you're funding the total replacement over only 30 years. A lot of things going on here with reserve studies, but the update with the site visit, when I cross out the component inventory, it doesn't mean you have to change what's there already, but there may be certain things that have to be added. The other thing that the new standards say, which is very important, is that the old standards used to say that it essentially the reserve study components are things you can see. Now it says that if there are things behind the walls that are common elements that you know are there, you have to fund for them on the reserve study. So if you have a clubhouse or a high-rise building with plumbing and electrical and things hidden behind the walls, they should be accounted for somehow in your reserve study, even though they're unseen. They are a common element that will require replacement. A lot of high-rises have run into special assessment problems because these type of things were not included. Again, the update with site visit includes everything else, a field visit, all that type of thing. Then there's on the right-hand side, the update without a site visit, which means you just take your old study and you update it without going out in the field to look at conditions. Now, if you look at the New Jersey legislation, it says that when you do a reserve study, you have to look at the components to see their condition. So you either need to do a level 1 or a level 2. Most people will do a level 2, and the level 2, based on the new standards, should provide for adequate funding because it's going to take into account the things I just spoke about. So these are the little refresher information. So what do? The full level 1 is generally done when the built community is constructed. When you're going through transition, you have it done to match the as-built community, that type of thing. But the recommendation is what you should do is you should update your reserve study with a level 2 study, a maximum of every 5 years. And the best practices say it should be updated every 3 years. The new legislation in New Jersey says that you can't go more than 5 years before you update your reserve study. It has to be a maximum of 5 years. It's a maximum of 5 years. It doesn't say less. It doesn't say anything. It just says 5 years. The other thing the legislation says is that, and like I said, it was effective as of January 8th, that if you currently do not have a reserve study, or the reserve study you have is more than 5 years old, you need to have a reserve study prepared or update your existing reserve study within 1 year of that legislation being passed. So you have until January 8th of 2025, if you're in that situation, to update and bring your reserve study current to meet the legislation if you either don't have one or the one you have is more than 5 years old. If you have one that is 3 years old, within 2 years, you need to update it to meet the legislative requirements. If it's 3 years, if it's 4 years old, you have 1 year. If it's 1 year, you have 4 years. Now, keep in mind, as I mentioned before, the reserve study standards legislation does not match the reserve study standards. Other than the updates, the critical difference that's included in the legislative requirements that is not in the national standards is that you need to include in the reserve study the cost and the timing for preventive maintenance. Very important. Now, let me tell you what the national standards say, because I said the national standards reflect maintenance, but they don't require it. What the national standards say is that when you're doing a reserve study for a community, you need to ask them if they have a maintenance schedule. If they don't have a maintenance schedule, you have to adjust the estimated remaining life on the components due to the fact that you're not maintaining them. If you do have a maintenance plan in place that you're doing, then you leave the estimated remaining lives, the full useful life, assuming the condition matches that, because you are maintaining them. Now, I'm going to give you an example of how that affects you in the end of the presentation, but keep in mind that the New Jersey legislation specifically requires that you include maintenance in your reserve study. It also says that you need to include the cost of updating the study. So if you're updating the study every 3 years, which is what the best practices say, and it costs $3,000, you should have in your reserve study $3,000 with a 3-year life, so you're setting aside $1,000 a year to update it. The other thing it requires, which I'll talk about in a few minutes, is that if you're required to do structural integrity inspections of your buildings, then your reserve study needs to include the cost of that structural integrity inspection and the timing for it. That's in this legislation, and you need to do it. So these are the things, and like I said, if anybody has any questions about this, please drop it into the chat box. I see, Jody, I hope you're monitoring, because I see there's 23 comments in the chat box. So
Yes,
feel free to jump in if anything has to do with this. And then the other thing that's a big question in terms of legislation is adequacy. What does adequacy mean? And you are required in this new legislation, and also it's in the public policy and it's in the reserve study standards, you are required to have adequate funding. The definition of adequate funding is that within 30 years from the date that you do your study, it should not drop below zero, where you need a special assessment or you need to borrow to be adequate. Now, if you look at the graph I'm showing you, the green line, well, the red line shows what's going to happen if this association continues to fund the way they're funding. They're going to run into a deficit. It's going to go with the red line means it's below zero. So they have a deficit. And when it comes time to replace something, they're going to need to borrow money, or they're going to need to special assess. But keep in mind, if you have a leaky roof, the roof isn't waiting for you to get the money. You're going to need to replace it. So if you're in a deficit, it's not adequately funded. The definition of adequate, which is in the legislation, is that it cannot fall below zero. Now, if you look at this green line, you'll see at the lowest point in year 2030, it drops down to zero, but it doesn't go below zero. Based on the legislation, that is adequate. But our recommendation, and most people who do reserve, or all people that do reserve studies, do not recommend going to zero, because it may be adequate theoretically, but the reality is that if something needs to be replaced a year early, or it costs $10 more to replace it, you're going to run into a deficit. So without going into, and that's called what's known as threshold funding, where you're above zero and you establish a threshold. I'm not going to go into how to come up with the threshold for your community. That's a completely other webinar, but this is what the legislation says, and I do not recommend that you drop down to zero. But when you're being measured to meet this law, that is what it's going to be. And if it goes below zero, you're going to have to get back to adequacy. And you have a number of years, which I can touch on if anybody would like me to, a number of years to get back to adequate funding by increasing your funding. So I'm going to leave that to see
Mitch,
if anybody has any questions about that, but it does require you to catch up and get back to adequacy. But keep in mind,
Mitch, we
this
have a
is the
request
definition of
to,
adequacy. So
we have
what
a
are the
request to,
standards that the legislation says and the public policy? The public policy does not match exactly. For example, the legislation says that the person who prepares your reserve study needs to have their RS designation, which is given out by CAI, the Reserve Specialist designation, or they need to be a licensed engineer, or they need to be a licensed architect. The standard that needs to be used, irrespective of who does it, is the National Reserve Study Standards of CAI or similar standards of another recognized national organization. There really isn't another similar standard. So the standard, these are pretty much the specific words that come out of legislation in New Jersey. And keep in mind, it doesn't have to be done by a reserve specialist. It can be done by a licensed engineer or an architect. But keep in mind, just because you're a licensed engineer or an architect does not mean you know how to do a reserve study. It's kind of a special art, as I'm sure you all know. So I would be very careful. And my suggestion is that you stick with a reserve specialist. And many reserve specialists like myself are also licensed engineers. For example, I have my RS and I'm a licensed engineer. So now, but this is the requirement. To put it in context on a national level, I think there's about 365,000 community associations across the country, if I remember the latest number. And, all of them, or the majority of them, are going to need to do reserve studies based on legislation and based on the banking requirements. Guess how many reserve specialists there are across the country? Less than 300. So if any, I'm too old for it, but if anybody wants to get into the reserve study business across the country, there's a huge opportunity because the supply does not meet the demand for people to do reserve studies. So now let's talk about maintenance. Maintenance, what's the definition and what are the types of maintenance? Maintenance is the process of maintaining or preserving something or the state of being maintained. I copied this directly out of the best practices report on maintenance. Maintenance is often referenced in 3 ways, and I'll touch on them: preventive maintenance, corrective maintenance, and deferred maintenance. Now, when you go into legislation in New Jersey, as well as the public policy paper it's based on, it specifically refers to preventive maintenance and corrective maintenance. It does not use the term deferred maintenance. The reason for that is that deferred maintenance means you do nothing. Preventive maintenance is a proactive plan aimed at spelling error, reducing the deterioration of the component so it can achieve its useful life. So if you have something with a 20-year life on your reserve study, you want to make sure it attains 20 years. So you proactively do something so that it attains that full useful life. Corrective maintenance means that if you don't do preventive maintenance and something starts falling apart, you have to fix it. It's repairs performed after detection of a problem due to a lack of preventive maintenance or aging. The other thing to keep in mind is corrective maintenance happens just because, even if you do preventive maintenance, because as things age, you can't predict how they're going to age and what needs to be fixed. The thing is that if you fix it sooner rather than later by doing corrective maintenance, it's going to cost you a lot less money. The other thing is, from the legislative perspective in New Jersey, when you do a structural integrity inspection of your building, if you need to, which I'll get to, the report needs to include in it any necessary corrective maintenance that needs to be done to the structure. The legislative requirements in New Jersey say that if that structural engineering report says you need to do corrective maintenance, that corrective maintenance should be included in the reserve study. It also says that in the national standards that corrective maintenance should be included. Now, the thing that sets corrective maintenance apart from the other components on a reserve study is that typically they're based on a cyclical replacement. You replace a roof every 20 years or 25 years. Corrective maintenance is a one-time thing. You shouldn't have to correct things over and over on a time frame. So corrective maintenance is something that's added to your reserve study with one time it happens. So you have to be very careful when that's added. You have to make sure that the reserve provider is only including it in there as happening once, not happening over and over again, but it should be included in your reserve study based on the legislative requirements. So what do? Deferred maintenance, you should never do it. Well, deferred maintenance means you're not doing it, but that's not the approach you should take. Preventive maintenance, you should all be putting together a preventive maintenance program for your community. When you do your reserve studies based on the New Jersey legislative requirements, you're going to have to do it. It has to be part of the reserve study. And then you should do corrective maintenance as needed, because if you don't, you're ultimately going to have to do it, but the sooner you do it, the less it's going to cost. So what does preventive maintenance include for community associations? Keep in mind, it's not just the fact of doing something to a component, but it includes regular inspections and servicing. So doing preventive maintenance includes doing regular inspections. So one of the things that's being done, if you're doing in the state of New Jersey, that regular inspection we're talking about is being done as part of the reserve study, because you're not only updating the components in the reserve study, but you're updating the preventive maintenance plan. So that takes place, that regular inspection takes place when you do the reserve study update. If you do the reserve study update from 3 years to 5 years, I think it's too far apart. And regular inspections can be done by management. It can be done by many different people. But in some cases, communities ask us to do a yearly inspection just to see if anything's deteriorating too quickly so that they can fix it or maintain it and not wait to 3 years. But it includes regular inspections. It includes checking roofs, elevators, fire safety system, on, and other shared infrastructure. The other thing that you should be doing is budget planning for maintenance. You should be allocating the funds, but in New Jersey, like I mentioned, from a legislative perspective, you are, because you have to, it's the law. What's corrective maintenance? Corrective maintenance is you should do prompt repairs if something breaks, as I mentioned, because it'll cost less. Emergency, you should have plans in place for dealing with emergencies affecting common elements. And you should have contractor management. You should have contractors that do the repair work or replacements when needed on an ongoing basis. So that's corrective maintenance. Now let's talk about structural assessments. And what I'm going to do, a lot of questions have come up about the legislation in New Jersey in regards to what does this really mean and what needs to be done. So that's going to be touching on now. But before I go on to structural, Jody, is there anything in the chat box about reserves that I should respond to now?
Yeah, so there's a couple of questions. So one is so assuming association has 10 years to catch up to fully
Jody, I
funded.
can't hear you. Oh,
you can't?
You know what I did? I didn't have my microphone on. I'm glad you could hear me because I couldn't hear you. Okay, sorry.
Okay, that's why you weren't letting me interrupt you before.
I'm sorry, I didn't hear you. I wish I could turn off everybody that way. All right, but
So assuming the association has 10 years to catch up to fully funded, how do they deal with a large reserve project that occurs in the middle of the period, like new asphalt or for a parking lot in year 6? In year 10, they would no longer need to show fully funded for the asphalt because of the recently completed. Yes?
yeah, that's I kind of assumed I'd get this question because what it says is, I know in the law in New Jersey, that if in order to get to adequate funding, which I described, that you need to set aside more than 10% of your last year's common area assessments. So let's say your last year's common assessments were $100,000. If in order to get adequate funding, you have to set aside more than 10% of that, or $10,000, what the legislation says is that you have 10 years to catch up. So if you're $10,000 short, it's $1,000 a year over 10 years. But if something needs to be replaced sooner than that 10-year period and will force you to go into a deficit, you have to catch up to adequate funding before that component has to be replaced, which is logical because it's going to need to be replaced. If you don't have the money, you're going to have a special assessment or you're going to need to borrow. The legislation, if it's a huge amount of money you can't catch up, I'm going to put an asterisk in there because the legislation does not say that you cannot special assess. So there are situations where you're going to have to special assess because of something like that. And so I think that addresses the question, but it also says if in order to catch up, it's less than 10% of your prior year's assessment. Keep in mind, when I say prior year's assessment, I'm not talking about your prior year's reserve funding. I'm talking about your prior year's total community assessment, which is much, much higher than just the reserve assessment. So if it's less than 10%, you have 2 years to catch up based on the legislation. The thing there's interesting, which is that there's a little conflict in the legislation. And what it says is that if it's more than 10%, you have 10 years to catch up. But at the same time, it says you have to update your reserve study maximum of every 5 years. So what happens if you have to catch up? You have 10 years, but then after year 5, you're updating your reserve study. The thing that's interesting, if you follow what I'm saying on this, but it's not a reserve presentation, is that as soon as you get that update date period at 5 years, when you're updating it, you're preparing a 30-year funding plan. to show adequacy. You no longer are locked in to that 5-year additional period to catch up because it goes out 30 years. And I've kind of really gotten into the weeds a little on that one, but there's a little conflict in the legislation that we all missed in terms of update period versus catch-up period. But the legislation is pretty clear that you do have to get to adequate funding by a period of time. And I hope I answered that question and more. Jody, are there any other ones about reserves?
Somebody wanted to know on their audited condo docs, they have deferred maintenance fund. Should they change that?
Another great question. In our industry for many, many, many years, including us, we're not exempt from this. People have been using the term deferred maintenance improperly. And they've been using the term deferred maintenance when they really meant preventive maintenance. Everybody I've spoken to now that the legislation is placed, which matches the best practices report on maintenance, is changing the terminology they use from deferred maintenance to preventive maintenance. So it's a great question. And we've been using the wrong term forever because we just have. So change it wherever you have it to preventive maintenance. The other thing that that question comes up is that the legislation says the maintenance needs to be included in the reserve study. What does that really mean? Because in some communities, they have a line item for preventive maintenance or multiple line items for preventive maintenance within their operating budget. So the question comes up, do we need to move all of those into our reserve study rather than in the operating budget? That dust has yet to settle, but from where it says included in your reserve study, I don't really see a reason why in the reserve study, you can't refer to another part of your budget where that preventive maintenance is. And that in essence will be including it in the reserve study. So that's another question that's been coming up. Jody, any other ones?
Yeah, somebody would also like you to repeat the definition of adequate funding.
Adequate funding essentially means that if you do a reserve study, within 30 years of doing that reserve study, if it goes below 0 in your fund account, you're not adequate. So, essentially, if you're going to need a special assessment or to borrow, same thing. But the concept is go out 30 years with a cash flow projection, and if it goes below 0, you are not adequately funded. Anything else?
I think we're good.
Okay, because I see there's 42 comments in there. All right, now I'm going to move on to the structural assessments. I'm going to talk about, there's a few different types of structural assessments. They're known as preliminary and detailed. I'm going to touch on what they mean, and there's a number of different approaches to do them. There's been a lot of questions about how do you do this? And so I'll touch on that. I'm not going to go into detail. This is really not meant to be an engineer's training program, but it's really to give you the concept of what it means. But first, let's talk about when you do a structural assessment, what does it mean and who needs to do it? What the legislation says is that the structural assessment needs to be done of what's called a primary load-bearing system of a building. Now, the primary load-bearing system, forgetting about these words here, because that comes out of legislation, it's a little technical in nature, means that if any one of these things of the structure disappears, rots away over years, and that means that a portion of the building or the entire building can collapse. So the primary load-bearing system is made up of columns, which are these vertical guys that hold up the building, these braces, which are diagonal, which if the wind blows, it keeps the building from falling over. The balconies, as I mentioned, were added. The beams, which are the horizontal. So if any one of these rot away, then the building can collapse. That's the primary load-bearing system. This is an example of what it actually looks like on a building. This is a steel building. So picture this. You can see my pointer if I'm not mistaken. If this column right here rusts away, this entire corner of the building will collapse. It's the primary load-bearing system. If this brace here rusts away and the wind blows, this upper part of the building will blow over. If this beam, this horizontal beam, rusts away, then the building will collapse in this area. So keep in mind that the primary load-bearing systems means that it's something that is not repetitive, which means if something happens to one of them, it can affect a portion of the entire building. And I'll show you an example of that, what that means also. But that's the primary load-bearing system. So buildings that have a primary load-bearing system that is constructed of concrete, masonry, steel, or heavy timber are are buildings that require to have a structural integrity inspection done. We get a lot of calls from people and say, this is what my building looks like. We need to have this inspection done. And a lot of times we can tell just by looking at the picture, but sometimes we can't. So we ask them if they have the architecture or the engineering drawings because we can look at them. The other thing we do now is that we include, when we do a reserve study, we'll evaluate your building as part of the reserve study to tell you whether or not we feel you need, based on the legislation, to have these structural integrity inspections done. So this is where it's needed. Now, in the state of New Jersey, there's a couple other things that are going on in different towns. For example, and as I mentioned before, in the legislation, it does not include doing the facades, looking at the facades. I will tell you that in Newcastle, Delaware, the legislation there does include the facades, but that was done later than New Jersey. And one of the things I've learned is once you get legislation in the works in a state, not just New Jersey, even if things change, it's tough to change the legislation. So, but in Jersey City, it requires that you do a structural inspection every 10 years, needs to be done by an architect and engineer, and it says for concrete buildings more than 6 stories. Now, as soon as I saw this, I said, well, what if it's a concrete building that's less than 6 stories that's falling apart? Because the primary load-bearing system is not based on the height of the building, it's based on the materials that it's made out of. So keep in mind, it's not just for high-rise buildings, but this in Jersey City says for concrete buildings more than 6 stories. What if you have a steel building that's more than 6 stories? On and on. Also in Jersey City, it says you have to inspect the facades every 5 years by an architect or an engineer. In Jersey City, it says the structure every 10 years by an architect or an engineer. The legislation in New Jersey says that the structural inspection needs to be done by an engineer. It does not give the option of it being done by an architect. Architects are not trained in engineering, and engineers are not trained in architecture. So in this case, it says architect or engineer, but keep in mind, when you're soliciting a proposal from somebody to do these inspections, make sure they have the qualifications. And I'll also mention that we've put together kind of a standard RFP that if you're selecting an engineer to do either a reserve study based on the new legislation or structural integrity inspection, we can provide you with a standard RFP to select a bid. It doesn't have Kipcon's name on it, but it is in conformance with this legislation if you'd like a copy. Jersey City, it says facades every 5 years for all buildings more than 6 stories, or all masonry facades more than 4 stories. For Cliffside Park, it says structure every 10 years, architect or engineer, steel, stick, brick, stucco, concrete, or fabricated panel structure, 4 stories or more in height, or if it has 12 residential units, even if it's less. It says facade every 5 years, an architect engineer, any building more than 3 stories, or if it's a brick building that's more than 20 feet, even if it's less than 3 stories, it would need to have the facade inspected. So I don't really know where all these things came from, but that's what they say. From listening to all the legal scholars and the politicians I've spoken to, if this is more stringent than what the state legislation requires, you do what is even more, what is the more stringent in your location if you're located in one of these places. So for example, in Jersey City, the structural criteria in the legislation is more detailed, has more requirements than what theirs does, but it does not include the facades. So in Jersey City, you should do the structural integrity inspection based on the legislation, and you should do the facades that's not included in the legislation. So that's the general concept of how it works. Now, the only other one is Hackensack. Hackensack says for all commercial or multifamily residential. And by the way, when we go back to these guys, Jersey City and Cliffside Park, it doesn't just say community associations. This is for any building. So in Hackensack, for any commercial or multifamily residential building, all parking garages, and I put these words in here because it doesn't miss a thing, open or enclosed parking garages below grade and above or below street level, they all need to be inspected by an engineer every 5 years. It does not include wood frame garages, but this is in place in Hackensack. A number of years ago, they had a collapse of a parking garage. That's why this is in place. And we have done many inspections of parking garages in Hackensack based on this type of thing. So what's not included? I talked about that in a primary load-bearing system. If one piece of the structure fails or rusts away, the building can collapse. Buildings that have very repetitive structures are not included. So for example, this is known as frame construction, what you're looking at. It's made up of a million 2x4s vertically holding up the walls and all kinds of different things. This type of structure is not included in the legislation to be inspected and having a structural integrity inspection. So this is not included, excluded. A lot of buildings are made this way. And that's because if one of these columns or something rots away, the building's not going to collapse. But then you have a hybrid, which have both. For example, this building on the bottom, this is known as a concrete primary load-bearing system with a podium deck. This podium deck right here, this horizontal deck, is made out of concrete, and it supports a frame-built building above made out of wood. So in this type of construction, the bottom, the podium deck, and this load-bearing system below it made out of concrete would need to be inspected, but what's above it does not need to be inspected. The reason for that clearly is if one of these columns in the bottom goes, this entire upper section is going to collapse with it. So this is kind of a hybrid that it needs to be partially inspected under the law. Now, this is the facade, just to give you an idea. The facade is the outside of the building and includes everything that's attached to the outside of the building. As I mentioned, in New Jersey, due to the collapse of the balcony, and I think it was Seabright, we were able to add the balconies to the primary load-bearing system, even though they're really not technically part of it, but those do need to be inspected under the New Jersey regulations. And that's included, as it says here, in the updated public policy. Now, why are the facades important? The facades are important because not only do they look good, but the facades have joints in it, expansion joints and things like that, where if it rains, water can get through them. And if water gets through them, it can rot away the primary load-bearing system behind it. So that's why it's very important, and that's in the legislation. Newcastle, Delaware is very specific. It's not for the structure of the facade only, but it's also for water infiltration. You need to check the joints and make sure that they're sealed properly so water can't get in. That's what the CAI updated public policy also includes, the facades and the water getting through the facades. All right, now let's move on to structural assessments. What's the protocol? This is where a lot of questions have come up. Now you'll see in here, it's broken down into two types of assessment, a preliminary assessment and a detailed assessment. Now the question that comes up a lot is, which I'll touch on, is that when you're doing an assessment of a building, there's a lot of the structure you can't see. So what do? There was one engineering firm a couple of weeks ago saying that, don't we need to take apart the entire skin of the building, the walls on the inside, the ceiling, so we can see the primary load-bearing system and the condition? That's what I want to touch on, because there's a preliminary assessment and a detailed. In both cases, you'll see here, it says ASCE 11-99, section 2.3. What that means is the American Society of Civil Engineers has put out a standard for inspecting the structure of existing buildings. That's referenced in the New Jersey legislation. And the protocol, actually in the standard, it's called a procedure, not a protocol. But the procedure/protocol included in there is what the legislation says you should follow. It says you should follow the ASCE protocol for doing the structural integrity inspections, which is very clear. There's a preliminary assessment and a detailed assessment. The preliminary assessment provides the initial data for estimating the structural adequacy, clearly. The basic steps include looking at all documents. Look at all the documents. The engineer has to, and by the way, these reports need to be signed by a licensed engineer, but you look at all the documents to see if there's anything in those documents for the association that will indicate that there's any kind of structural problems. You do a site inspection. So you're looking at the entire building. And I'll show you what that means, because there are certain parts of the structure you can absolutely see, and there's certain part of the structure you can't see. You do a preliminary analysis based on this, and you write a report with your preliminary findings and recommendations. That's what the preliminary assessment is. No matter what I talk about today in the next section of this presentation, you always need to do this type of visual preliminary assessment for whatever you're doing, because that's the starting point. Then you get to a detailed assessment. Again, now this is section 2.4 of ASCE, and it's performed as a result of the findings of preliminary assessment. The purpose is to determine if the building requires rehabilitation, to identify deficiencies and recommend alternatives for rehabilitation. Now, keep in mind that if and I'll show you some examples, the detailed assessment is only needed if you see problems when you're doing the preliminary assessment. And the other thing it does is, rather than having to take apart the entire building to see if there's a problem, you're going to look at the entire building, and then you're going to focus on certain areas only if you see potential problems. And I'll show you some examples of that in a second. Now, in the New Jersey legislation, it says that the report has to be prepared by a New Jersey professional engineer. It includes the condition, the first report, which I'll tell you about the timing of these, but the first report, or should I think I have the timing here somewhere? If I don't, remind me and I'll tell you what it is. But the first report includes the condition of the primary load-bearing system, the required maintenance of the primary load-bearing system. So if you're doing a structural integrity inspection of your building, you're also doing a reserve study, and this required maintenance that's included in this report should be put into the reserve study. And it also says when the next inspection needs to be performed. The periodic inspections after the first one include, again, the condition of the primary load-bearing system, but also any progressive deterioration. Is it getting worse from the first report? Which means it's very important to keep the first report that you're doing, which is known as a baseline report also. And whenever you do updates to that report, a copy of that report needs to be given to the firm who's doing the updates, because they're going to see if there's any progressive deterioration. Again, required maintenance and when you should have the next inspection. And what if you can't see the primary load-bearing system? I'll touch on that in a second. Now, there's a slide in here somewhere, but let me touch on it now. So the first inspection, I'm assuming everybody here today, I think there's 88 of you now, everybody here today is working on existing buildings. If your building has this type of structure and is more than 15 years old, you need to have this structural assessment done within 2 years. That's the bottom line. You need to have it done within 2 years. And then each subsequent inspection needs to be done a maximum of every 5 years. So that's what you need to do. If your building has this kind of structural system and is less than 15 years old, you need to have a structural assessment like this done within 1 year of after it turns 15 years old. The only asterisk there is that if you ever notice any deterioration or any problems with any part of the structure, you need to have an inspection done within 60 days at the latest, or if it's a real problem, you need to have it done immediately. But from a timing perspective, if you have a building, and most of the buildings I think that you're managing that require this are more than 15 years old, you need to have your first inspection done within 2 years. That's the law. That's what it says. So keep that in mind. The other interesting fact, if you find it to be interesting, is you can find information about the ages of buildings in New Jersey, and it comes from the Census Bureau. And multifamily residential buildings in the state of New Jersey, which are owned, which really lead toward community associations, I think it says 60–70% of them at least are more than 15 years old. So those buildings, it's a lot of inspections are going to need to be done. So now let's talk about the different types of inspections. The preliminary structural assessment, like I said, is based on visual. It's a visual inspection of the building. The cost for that is generally low, and it includes on-site inspections, inexpensive, physically inspecting the building's components. And keep in mind that what happens if you can't see something, which I'll get to in a second. The pros are that it's required of just about anything you do, you have to do a visual inspection. You have to start with it, and it's included, and in the definition of preliminary assessment, ASCE, it includes visual. It's relatively straightforward, provides immediate feedback, and can identify obvious signs of distress, deterioration, or damage. So I'll get to this in a second, because what that's saying is, even if you can't see the structure directly, if you do visual observations, you can see obvious signs of distress, deterioration, or damage, which then would lead you to a detailed assessment. Allows for visual inspection of structural elements and identification of visible defects. The problems with it is it's limited to identifying surface level defects and visible signs of damage, and it requires a licensed professional who understands the effect of deterioration on structural capacity. The reason why the legislation requires this to be done by a structural engineer is because most people can identify the damage when I show you some pictures, but an engineer can tell you whether or not that damage affects the structural capacity of the building. So there's a big difference there. And also keep in mind that you really need to talk to whoever the engineer is that you're going to hire to do this, because most structural engineers are trained in school to design new buildings. they're not designed, they're not trained, and most schools that I know of don't include it. How do you inspect an existing building structurally as opposed to designing a new one? So you have to be very careful about who you select to do it. But this is the first step is visual. And this, when you're looking at a visual, you're looking at a number of different things that may indicate that there's damage behind the walls or ceilings that you can't see. For example, cracks to finishes, bulging or bowing, staining or discoloration, uneven or sagging floors, settlement or movement. These are the type of things you look at even if you can't see the structure. Rot or decay, rust or efflorescence, which I'll touch on in a second, cracking or spalling concrete, improper repairs or modifications. So what does this look like? This is something we have a bowed wall. In this case, the bowed wall, you can see it, it's in the basement, but in many cases, you might have a wall in front of this wall, a covering wall, but you'll see that the wall is moving outwards, which is a sign that there's a problem with the structure behind it, which then what happens? You say you need to do a detailed inspection in this spot by taking out the walls or doing something to see what's going on behind it, because there's indications of structural problems. Here, a settlement of a floor. Bowing of the floor. You look at the bottom of the floor and you see this opening that's occurring. That may be indicative, depending on where it is and what the engineer with experience says, may be indicative of a problem with the structure because the floor is sagging. These are the type of things you look for. All right, here you're seeing moisture stains and signs of rust. What does that mean? It means something behind there, it's made out of steel, is rusting. So that's part of the structure. You have a beam right here to the right. So that might be the structure. So you could look at this as part of your visual observations, but then the recommendation is to open up the ceiling in this area to see what's going on with the structure. Here, this is something, now you're seeing two things. You're seeing rust to the right and this white powder, which is known as efflorescence. That's the beginning signs of problems because you have a concrete beam here that has a steel reinforcing in it. As the water goes through the concrete beam, the first thing that happens is it carries the salt within the concrete to the surface, and it comes out as white salty material. Then what happens over time, it starts to rust the reinforcing in the concrete and you start to see rust. You should do some kind of corrective maintenance to stop the water as soon as you see the salty material. But as soon as you see the rust, then you know that there's some deterioration of the structure and you need to do something. But these are some of the signs you look at when you're doing visual observations that lead you to do a detailed assessment. Here's another one. That if you see something like this, they put in a gutter and downspouts in the ceiling. In this case, it's a parking garage, so the water doesn't drip on the cars. As soon as you see this as part of your visual observation, the detailed inspection includes taking down that gutter system, see what's going on behind it. We took this down and found that the concrete behind it was deteriorating structurally, but it was hidden because they put in the gutter and downspout. If anybody has something like this in any of their buildings, you should take it down because it's hiding problems. We see a lot of times blue tarps and things to direct water away from cars. Here's one of my favorite pictures, this one. This is a steel beam that's covered with fireproofing, so you can't see directly the steel beam, but there was water coming through, so they directed the water to the side so it doesn't drip on the cars. And now it's going up against this steel beam, and now you're starting to see rust because they're directing all the water right at the structure. So a preliminary assessment, you'll see this. The recommendation is, first of all, get rid of this thing so the water doesn't point at this beam. But now you have to take the fireproofing off of that beam to see how much structural damage has been done to that beam. The other thing is, you look here, you see there's a ceiling to the side of the beam. In many cases in a parking garage, if you're below the building above, you have a ceiling. If you're not below a building above, it's just exposed structure. So now you need to open up this ceiling also to see if there's any structural damage above the ceiling. But that's the difference, how you look at things to go from a preliminary to a detailed assessment. Steel is very easy to look at. Steel, you can see immediately, you can see if there's any structural problems. The detailed assessment you need here is really, how do I fix it? This is a steel beam that's rusted away. Detailed structural assessment, sometimes the things that happen next is you do invasive testing to observe the underlying structure. Then you may need to do material testing. The material may look bad. You may need to take some of the material, send it to a lab to see if it still has the strength it was supposed to have. The structural analysis. Now what do? You go out and look at all the beams, you look at everything you can see and say, now we need to analyze it to see if it's structurally sound. So you need to do a structural analysis, which is mathematical modeling. I'm going to show you what it looks like. But in order to do this, keep in mind, you have to see the structure, where you think there are problems. You have to know the size of the beams. You have to know the size of the columns. You have to know the materials. There's a lot of information you need to know. That's why it says moderate to high, the cost to do this. But structural analysis, it provides data on the structural performance. It shows the stresses, strains, all this kind of stuff. The con is that it's pretty expensive, relies on specialized knowledge in structural engineering, relies on visual observations to see what the building is made up of. But here's what it looks like. Just an example. Hate to be an engineer, but I'm going to be it a second. This is structural layout of a building. This shows the beams. This shows the columns. This shows the building. Each one has a number on it that shows what it is what is the material, what type of beam is it. So you take this, then you apply to it in the computer model, the dead loads, the live loads. These are the wind loads coming from the side. And again, this is based on what you see in the field. And then you do an analysis through the computer, and wherever it's red, it says that it's failed. Wherever it's green, it says it's okay. But this is the type of structural analysis that could be done as part of a detailed assessment, not as part of the original. Then there's also non-destructive testing you can do. It's moderate to high in cost, and you can evaluate structures depending on factors such as the size and condition of the structure, but it can get very expensive, but it can be localized also. And what you do is, how do you look to see the condition of the structure, how it's built, without taking it apart? It's called non-destructive. The pros are that it's non-destructive. You don't have to take anything apart really. The defects, you can see things through this that you can't see by just visually looking at it. It's early detection of deterioration limit, but the cons are that it only goes a certain depth into the concrete, requires specialized equipment, all kinds of things like that. But what does it look like? Here's a concrete beam. Now you look at the concrete beam, this is a piece of reinforcing steel behind the concrete that has been getting rusted. And when it rusts, it expands and the concrete pops out and it loses its strength. The steel strength gets less because there's not as much steel, it rusted away, and the concrete is gone, so it loses its strength. The thing that protects this concrete from moisture is the distance from the concrete to the surface of the concrete. So the building code has certain requirements of what that depth needs to be. But in some cases, when it's built, it may not be the right depth, so it's exposed to moisture more quickly. So there's one way to do it. I'm just showing you a couple examples. It's called it's non-destructive testing, where you're actually doing X-ray. You're doing an X-ray to see where is that steel and is it corroded without actually seeing it or seeing any rust. So this is an example of a balcony on a high-rise building. This is what it looks like looking down on it. And then this is the X-ray on the left-hand side. This shows satisfactory information where these lines, the different colors, are where the reinforcing steel is, what the size is, blah, blah, blah. But on the right-hand side, it says unsatisfactory, because you do an X-ray and you find that the steel may be rusted, it may be too close to the surface, so water's getting to it. But this is just one example of how you can do non-destructive testing to see what's going on, primarily inside of concrete. This is one way to do it. Then you can also do thermographic analysis. Thermographic analysis essentially is primarily going to tell you how the water is getting into a building, where it's getting in, if it's getting in. And in some cases, it actually can show you the structure, but you essentially just take a camera, take a picture, relatively low in cost, and based on temperature differentials in the surface you're looking at, it can tell you where the water is, and sometimes it can tell you where the structure is. So here's an example. This is looking in, on the right, you see what you see it up on the left, you see the top. On the right is a thermographic picture of it, and it looks like, based on the temperature, that there's water behind the brick that could be affecting the structure. So this is how thermographic evaluation is done. So what do you do? Let me go back. What do? You have to plan. Plan. So how do you do that? The proposed protocol for taking into account reserves, maintenance, and structural integrity are have a reserve study, and a lot of this is legislatively required, but it's what the protocol is. Have a reserve study prepared and funded and updated every 3 to 5 years. But how often you should update is depending on the funding plan used, the age of the community, the type of the buildings. Develop and implement a preventive maintenance schedule for all common area components and update at the same time as a reserve study. Perform periodic structural inspections to reflect the age, condition, and type of building. And this is something, just because the legislation says that it's only for primary load-bearing system type buildings, depending on your building, you may want to have an engineer come out and look if you're having concerns about the structure anyway, even if it's not kind of building. The Fannie and Freddie requirements do not limit what they're talking about to buildings that have this kind of primary load-bearing system. They pretty much say it's for all types of buildings. Prepare and fund a budget to reflect the above and review each year. How often for the periodic inspections? I mentioned this already. I pretty should have moved this slide up about 20 slides. First inspection, if it's within 2 years of holding to 15 years, 1 year when it becomes 15, and maximum every 5 years after that, or in all cases within 60 days if you see damage. What's the results? You have potential life cycle cost savings. Investing in preventive maintenance to lead to significant life cycle cost savings by extending the lifespan of common elements in your reserve study. I'll show you how that affects you in a minute. Reducing the frequency and severity of repairs, because you're doing inspection, you're finding them, and you're fixing them before they get worse and a lot more expensive. Improving energy efficiency. If you do maintenance on your mechanical systems, they're going to operate better. And I would say in most places where you have a lot of mechanical equipment, you have a maintenance contract with a vendor. So hopefully they're looking at the equipment to make sure they're efficient. Minimizing emergency repairs. If you have to do something in emergency, it's going to cost a lot more than it's not. What are the life cycle costs in the community? It's the life cycle refers to the total cost of owning, operating, maintaining a building or its components over their entire lifespan. So what does that really mean from a dollars and cents perspective? The cost of preventive maintenance is 5 to 15% of the replacement cost of a component. General rule of thumb. So if you have something that's going to cost you $100,000 to replace, the maintenance of the preventive maintenance on that item over its life is somewhere between 5 and 15% of the replacement cost. The cost of corrective maintenance. So let's say you do not do preventive maintenance and you have to fix something because you didn't do it. The cost of corrective maintenance is 3 to 5 times higher than the cost of preventive maintenance. And that's the cumulative amount. So if you're setting aside 15% a year and you don't do it, and then you have to fix it instead, multiply that times 3 to 5 times, and that's how much it's going to cost you to fix it. The lack of preventive maintenance can result in reduction of components' useful life of 30 to 50%. So if you have a wood deck, as an example, and you don't maintain it, instead of having a 15-year life, you may have only a 7.5-year life. The lack of preventive maintenance will result in reduction in property values. If you don't maintain something, somebody comes to buy in your community, the property values are lower. Now let's take a quick, this is my last slide because everybody other than questions, a component example. You have a $100,000 component with a 20-year life. That means you're setting aside $5,000 a year. Keep in mind, this is for one component, not all of them together. So this is a very small amount. Add 15% to that component for preventive maintenance. Now it's $115,000. It still has a 20-year life, and that comes out as $5,750 a year. Now, let's say you're not doing preventive maintenance. You reduce the useful life by 30%. It's $100,000, but now you only have a 14-year life. So 100,000 divided by 14 is $7,142 a year, as opposed to $5,750 a year if you do preventive maintenance. The other thing to keep in mind, which it doesn't say it here, if you're not maintaining it, you generally don't find out. You're not budgeting for this from day one. You're going to find out that you only have 14 years left when you do your reserve study at 5 years or 10 years. So you got even more catch up to do. So the annual savings with preventive maintenance is $1,392 a year. 30 years, it's $41,760, which just is for one component. And again, keep in mind that the catch up is going to be much more because you're not going to find out what the lack of maintenance is doing until you've had that component for a number of years already and inspect it. So now I'm going to stop my share. And it is, let's see what time it is. It is, 10:40. I went over my time. Sorry, this was supposed to, Kevin, hi there. How are you? So any questions? We got 70 questions here. I have a call at 11, but I'd be happy to stay until 11. And
Yeah, Mitch, so there was a lot of questions from people with individual questions about, whether they need a structural inspection. Maybe you could just go over what they can do to find out.
That's the question that comes up all the time. In a lot of buildings, if you just send us a picture, we can pretty quickly tell if it's one of those stick frame buildings or if it has this primary load bearing system. So most of the times you can tell by just looking at a picture. For example, I'm looking at Jackie Rogers looking out the window. Now I'm looking out the window that in that picture, you see those buildings. Those are stick frame buildings. I can tell by just looking at them. They don't have a primary load bearing system. So, but the way to tell is look at the architectural drawings if you're not sure. Look at the engineering drawings. The person who's doing, if you have a company that's doing your reserve study, they should be able to tell you. I would, if I was a manager, I would not take on the responsibility of making that decision though. So.
Okay. So with the frame built systems and the balconies, how does that, I mean, if it's a frame built system and they have a balcony, does that require an inspection?
Good question. Keep in mind that we're talking about built balconies and decks. If you have a frame built building, your balcony is probably, in my words, jargon, a deck, which means it's made out of wood, not made out of concrete. So the balconies that we're talking about are typically concrete balconies that are included. If you have a stick frame building and it has a wood deck, the condition of the deck would be evaluated as part of doing the reserve study because you'd be assigning a useful life for it and looking at the condition. One thing I will warn you is that do not expect that the person who's doing a reserve study is looking at the structure of your decks. The reserve study does not require it. When you have your RS designation, more than 50% of the people who have their RS are not even engineers. They're doing budgets for replacement costs. And so don't expect that the person doing a reserve schedule will tell you if you have a structural problem with a deck. But wood decks do create problems. We've seen many, many decks where the biggest problem we see is that the handrail posts are not connected correctly, that the wood is rotting away too fast. And we see common problems with wood decks all the time, but it's not a requirement of the primary load bearing system.
Okay. And then how does the structural inspections relate to single family homes?
The single family homes are not included.
Okay. And then is a porch overhang considered part of the facade?
I would have to see a picture of, because now we get back to deck, balcony, that type of thing. But I would say if it's concrete, it's probably included. If it's wood, it's probably not included.
Okay, I think that's,
That's all 70 comments?
well, I answered some. A lot of
Well, if
them
any-
were individual structural inspection questions, you know.
All right, well, if anybody has any additional questions, feel free to email it to us. Also, keep in mind that if you would like continuing education credits for this, just send us an email and we'll send you whatever we need to send it to you. So you have that, the CEUs. And if you ever have any questions, feel free to reach out to us. And Jody, we do regular webinars. I forget, I'm not sure what the next one coming up is, but if you're on this list, then you're going to get our emails for upcoming. And if you ever have suggestions about webinars and topics, let us know. I will tell you that this topic, I've done this or similar presentations about 15 times now. And we've had from 80 people show up, like today, I think there were 85 to over 200. So this is a hot topic right now in New Jersey, that's for sure.
Yeah, I've put my email in the chat for anybody who wants to reach out. If you've put a note in there that you wanted a CEU certificate, I'll take that, or you can just email me.
And if you also, Jody, we have the emails for everybody. We can send them a copy of the presentation, as well as we can send a copy of the reserve study standards, as well as the best practice on maintenance report and the public policy report. We can send all of that to everybody. Some
Right.
reading to put you to sleep at night. All right, everybody. Sorry I went over a few minutes, but it seems like everybody hung out. Have a great day. I appreciate you coming, and have a great day. Thank you very much. I hope it helped.
Thanks. Bye-bye.
Bye.
Thank you, Mitch.
Thank you for coming, everybody.
Thank you, sir.
Thank you.